Welcome to solverfy.
For the first part, we are going to use the analysis in the text of Thomson's E by M experiment, which gives E over M to be equal to E square over 2 times voltage times V square. And this gives E square to be equal to 2 times E over M times V square V. And therefore, the graph of E square versus V should be a straight line, as you can see, following from the equation y equal to mx plus c, where c is 0 here, x is v, y is e square, and m is the slope. So slope is equal to 2 times e v square over m. For part B, we can find the slope using two easily read points on the graph. So using the 100, 200 and 300, 600, we get the slope to be, so let's call the slope to be m, to be equal to 600 times 10 to the power 8 v square over m square minus 200 times 10 to the power 8 v square over m square. So this is delta y, and we have to find delta of x, which is 300 volt minus 100 volt, and this gives the slope to be 2 times 10 to the power 8 volt per meter square for the slope. Now we can use this value that we found for slope over here. That means 2e v square over m is equal to 2 times 10 to the power 8 volt per meter square, and this gives the ratio of E by m to be equal to this value, slope. So don't get confused with m and m here. Let's call this m double dash to distinguish the slope from mass. So this is sorry, slope times 1 over 2b square, and this gives the ratio to be equal to 8.65 times 10 to the power 8 coulomb per kg, which means that mass is equal to this value, sorry, the charge of the electron over this value, and charge of the electron is 1.6 times 10 to the power minus 19 coulomb. So we are just taking the magnitude of the electron charge. So the mass is equal to 1.85 times 10 to the power minus 28 kgs. And for part C, we have to find the voltage given the electric field and the distance between the plates. The electric field is given to be 2 times 10 to the power 5 volt per meter, and distance between the plates is given to be 0.06 meter. Make sure you convert this into meter while using this equation, and we get the voltage to be 1.2 times 10 to the power 3 volts, or we can write this as 1.2 kilovolts. For part C, we are going to match the energy. So energy is basically E times V, the potential energy, and this is equal to the kinetic energy. So this is basically conservation of energy that we are applying, and this gives the velocity to be 2 times E times the voltage over m, and we have to take the root over, and this gives the voltage to be sorry, the velocity to 8.32 times 10 to the power 5 meter per second. Make sure you use the value of voltage given in the fourth part, which is 400 volt, and not the voltage that we calculated here. And your results might vary from mine, because due to the inaccuracies maybe in determining the slope of the graph. So if your result is close enough, the order is exact and this magnitude is close enough, then